Hello everyone, welcome to my chemistry class. My name is Flizio and I'm from IPA B. So first, I want to thank you guys for joining my physics class yesterday. I hope you understand what I have discussed. So today we are going to move on to chemistry. And the topic for today is the naming of ionic compounds. So let's start. So what is ionic compounds? Ionic compounds is compounds consist of a metal and non-metal. So for example, here we have NaCl, which is sodium chloride. So sodium is a metal and chloride is a non-metal, which makes it an ionic compound. Next, we have MgBrO3 multiplied by 2, which is magnesium bromate. So magnesium is metal and bromate is non-metal, which makes it an ionic compound. So here are the types of ionic compounds. First, we have binary ionic compounds, which is an ionic compound with two elements. So for example is NaCl. They are two elements. The next we have ternary ionic compounds, which is ionic compounds with three elements. So for example is MgBrO3 multiplied by 2. They have three elements. And the last one we have ionic compounds with monoatomic cations of variable oxidation number. The example is iron. Iron has oxidation number of +2 or +3. So first, let us start from naming of binary ionic compounds. So the rule here is simple. The name of the first element plus root word of the second element plus type. So here are the examples. First we have NaCl. So Na is sodium and Cl is chlorine. So the name of the first element plus the root word of the second element plus I. So the root word of the second element is chlorine plus I, which makes it chloride. So the answer is sodium chloride. Next, we have Mg3P2. Mg is magnesium. Mp is phosphorus. So phosphorus plus I equal to phosphide. So the answer is magnesium phosphide. And then next we reverse it, so we need to find the chemical formula from the name. So how to find the chemical formula from the name? So right here we have lithium and oxide. We can find it by first finding the oxidation number of each element. So how to find the oxidation number? So we can find it from the periodic table. So here, if the elements is in 1A, the oxidation number is +1. And then 2A is +2. If it is in 3A, the oxidation number is 3. And 4A is -4. 5A is -3. 6A is -2. And 7A is -1. So let's go back to the example. So lithium is in 1A. So the oxidation number is +1. And oxide is in 6A. So the oxidation number is -2. So to find the chemical formula, we cross multiply this. So this one is 2 and this one is 1. So the answer is equal to lithium 2 and oxygen. As you can see right here. So we have calcium sulfide. So calcium here is into 8. So the oxidation number is +2. And sulfur is in 6A. So the oxidation number is -2. So we cross multiply this, which makes it 2 and 2. And here we can simplify it to 1 and 1. So the answer will be calcium sulfide, CaS. Okay, so let us continue. So let's move on to the next one. Naming of ternary ionic compounds. So ternary ionic compounds consist of cations. The cations is NH4, which is ammonium, and the ion is +1. And then we have NH3, which is ammonia, and the ion is 0. And here are the anions. So anions is divided by 3 different ions, which is -1, -2, and -3. So here are the list of compound with -1: ClO3, BrO3, IO3, NO3, and MnO3. With -2 is CO3, SO4, and CrO4. And the last one with -3 is BO4. And here are the guidelines for naming the ternary ionic compound. So if it is in the original number of oxygen atoms, so right here the rule is root word of the first element plus 8. So the example here is ClO3. ClO3, as you can see in the list of anions before, is in the original number of oxygen atoms. So the root word is chloride plus 8, which makes it chlorate. Next, we have if it is with one less oxygen atom. So the rule here is root word of the first element plus I instead of 8. So example, we use again ClO. Here is ClO2. So the original is ClO3, but here it is ClO2, which means it is with one less oxygen atom. So chlorine plus I will make it chloride. Next, we have if with less 2 oxygen atoms. The rule is hypo plus the root word and then plus I. So ClO, the original is ClO3. Right here is only ClO. So it is with less 2 oxygen atoms. So hypo plus chlorine plus I will make it hypochlorite. The last one, if it is with one more oxygen atom. The rule is per plus root word of the first element plus 8. So example, ClO4. The original is ClO3. So here is with one more oxygen atom. So per plus chlorine plus 8 is equal to perchlorate. So here are the examples to help you better understand. So here we have Mg and BrO3 multiplied by 2. So Mg here is magnesium. And we have BrO3. And BrO3 is in the original number of oxygen atom. So bromine plus 8, which is bromine. So the answer is here is magnesium bromine. Next, we have Al2 and SO2 multiplied by 3. So Al is aluminum and SO2. So the original number of SO must be equal to SO4. So in here it is SO2. So it is with 2 less oxygen atoms. So the rule is hypo plus root of the first element plus I. So hypo plus sulfur plus I, which is hyposulfite. So the answer is aluminum hyposulfite. Next we have aluminum percarbonate. So aluminum is plus 3. And percarbonate must be negative 2. So we cross multiply. So must be 2 and this one must be 3. So this one must be Al2. And this one, because it is percarbonate, so it is with one more oxygen atom. So the original is CO3. So plus 1, we make it CO4. So the answer is Al2 and CO4 multiplied by 3. Next, we have ammonium chromate. So ammonium here is NH4 and it is plus 1. And here we have chromite, which is negative 2. So we cross multiply. This one becomes 2 and this one becomes 1. Ammonium is NH4, that means so it will be NH4 multiplied by 2. And here chromite, so the original is CrO4. Because it is chromite, that means it is with one less oxygen atom, so it will be CrO3. So the answer is NHO4 multiplied by 2 and just CrO3. Let's continue. So the last one, I'm going to discuss the naming ionic compounds with monoatomic cations of variable oxidation number. So here are the list of cations. So as you can see the table below, here are the oxidation number and here are the element or elements. First we have plus 1 or plus 2. And the elements are copper and mercury. Next we have Cu and Hg. Next we have plus 1 or plus 3. And the element is gold or Au. Next we have plus 2 or plus 3. And the elements are Fe, Co, and Ni, or iron, cobalt, and nickel. Next we have plus 2 or plus 4. The elements are tin and lead, or Sn and Pb. Next we have plus 3 or plus 5, and the elements are arsenic and antimonous, or As and Sb. So here some of the elements here, if we use the classical system, which I will explain later on, must use Latin name. So right here, Cu must use Latin name Au2, Fe, Sn, and Pb. So here are the Latin name. Cu or copper must be copper. Au or gold must be aurum. Fe or iron must be ferrum. Sn or tin must be stannum. And lead or Pb must be plumbum. So here are the types of systems. First is the stock system. So the stock system is the use of Roman numeral to represent the number of charge carried by the cation. So the rule here is the name of the first element plus Roman numeral representing the charge enclosed to a parenthesis. So the example here is Cu, and it is plus 1. So copper and the Roman numeral 1. Next we have Pb, and it is plus 4. So the answer is lead and Roman numeral 4. Next, now I'm going to explain about the classical system. Classical system is the use of the suffixes us or ig to represent lower or higher oxidation state of the given cation. So here are the rules. Root word of either the common name or Latin name of the given cation plus the suffix us or ig. So here, why we need to use the Latin name? Because the classical system the rule is using either the common name or Latin name. So in the classical system, we must use the Latin name of those that I said before. So here are the examples. First, we have AU and it is plus 3. So the oxidation number of AU is either plus 1 or plus 3. And here it is plus 3. So it uses the higher charge. So if it is higher charge, we need to use the suffix x, suffix ig. And gold Latin name is aurum. So aurum plus ig, which is auric. Next, we have SB, and the oxidation number is plus 3. So SB, the charge is either plus 3 or plus 5. And here it is plus 3, so it is the lower charge. So the lower charge must use the suffix us. So antimony plus the suffix us will become antimonus. So here are the examples. First, we have FeBrO4 multiplied by 3. First, we name it using the stock system first. So Fe is iron. So here we have BrO4. So because the cations have two possible charges, we first define the charges of the second element. So BrO4. So BrO4, the charge is -1. And it is multiplied by 3. So it is equal to 2 -3. And to make it 0, Fe must be equal to positive 3. Right here. So Fe is iron using the Roman numeral 3 plus BrO4 is with one more oxygen atom, so bromine. So per plus bromine plus 8, which is equal to per bromine. So the answer is iron and then Roman numeral 3 and then per bromine. Now we continue to the classical system. So yeah, it is plus 3. So yeah, because so here it is plus 3. So iron have stable charges between plus 2 or plus 3. So here it is plus 3. So it is the higher charge. So if it is higher charge, name of the first element plus the suffix ig. And the Latin name here is ferrum. So ferrum plus ig is equal to ferric and plus perbromate. So the answer is ferric perbromate. Next we have COS. So we define first the charge of S. Sulfur is -2. So to make the ion charge is equal to 0, CO must be plus 2. So CO is cobalt, Roman numeral 2, and then sulfide. Next, we continue to the classical system. So because it is plus 2 and Cobalt have the two possible charges are +2 or +3. So because it is +2, it is the lower charge. So cobalt plus us. So cobaltous and then sulfide. Next we have mercuric percarbonate. So percarbonate is -2. And to make it equal to 0, it must be +2. No. Percarbonate is -2. So mercury has two possible charges. So percarbonate is -2, and here it is mercury. So mercury has two possible charges, which is +1 or +2, and because it is mercury, so it uses the higher charge, so +2. So this one, we cross multiply, simplify it to 1 and 1. So Hg and CO4. So next we have ferric sulfide. Iron have two possible charges, which is +2 or +3, and because it is ferric, so it is the higher charge, we use +3. And then sulfide. So sulfide is -2. So we cross multiply, this one 2 and this one is 3. So Fe2, and then because it is sulfide, the original is SO4. So because it is sulfide, it is one less oxygen atom, so it becomes SO3. So the answer is Fe2 and then SO3 multiplied by 3. So thank you. So here is the lesson for today. I hope you understand what I explained today, and I apologize for any mistaken words that I said. So once again, thank you for watching.